Hi, it's Mr. Townshend here. This is the 7th video looking at the reaction of organic compounds. In this video, we're going to look at the reactions of acyl chlorides. So acyl chlorides are, I guess, summarized by their wanting to substitute the chlorine on the end of the carbonyl group with any other group or atom. So you'll see that all of the types of reactions they undergo are similar. You're taking away the chlorine and you're adding something else. Whether you're adding ammonia to make an amide, or you're adding an amine, which makes a more complicated secondary amide. So these are both substitution reactions, though the adding the amine is called a condensation reaction. We could add an alcohol, replace the Cl with an alcohol, to produce an ester. This is a specific type of substitution reaction called esterification. Or we can add water to replace the chlorine to make a carboxylic acid. So that's a summary of the 4 types of reactions we're going to look at in detail. Okay, so first let's look at the substitution reaction with water. So when we add water to the chlorine here on the end of this carbonyl group, what's going to happen is the OH from water is going to replace the chlorine, and then the chlorine is going to then bond with the extra hydrogen from water to make hydrochloric acid, which is over here on the right. Because we've replaced the chlorine with an OH, we get a carboxylic acid. So this reaction happens readily. If you put an acyl chloride into water, it will fizz and react vigorously. This is often used as a distinguishing test for acyl chlorides. You could add ammonia to your acyl chloride. Again, you've got this acyl chloride functional group that is very reactive. It wants to substitute. We've got the ammonia here. So again, we're going to take away the hydrochloric acid and have this amine group replaced with the chlorine was to make it a primary amide. Remember, a primary amide is an amide the nitrogen of the amide group has only joined to one carbon. That's what makes it a primary amide. Right, so let's look at another type of reaction that acyl chlorides have. This reaction is called an esterification reaction, a reaction where an ester is made. Now, this is also called a condensation reaction because when this reaction happens, we take 2 molecules here, so 2 separate molecules, we join them together, and when we join them together, we also make an extra product of a small molecule, either hydrochloric acid or water. That is how we identify a condensation reaction. Also notice, really what we're doing is we're taking away the chlorine here and replacing it with this whole molecule. So this is a type of substitution reaction. But generally, we call it esterification or condensation reaction. So we've got this acyl chloride functional group turning into an ester functional group. What happens is this alcohol part here, so we lose the chlorine from here and the hydrogen from here, and then it joins together and it produces this ester. And remember the extra product, which is our condensate, HCl, which is why it's called a condensation reaction. Okay, so the next type of reaction that is also a condensation reaction, doesn't have a specific name, is when we add an amine. So if we take, again, if you think we're taking this acyl chloride, we're going to take the chlorine off and we're just going to join it where the other functional group is. Remember, we're taking an HCl away. So this nitrogen is going to lose one of its hydrogen but keep one of them on the other side. And we get this amide join here. This is a secondary amide because the nitrogen is joined to 2 other carbons. So that's the 4 types of reactions that we need to remember of acyl chlorides. So let's just summarize those. So while you're waiting, just pause the video, sketch this down, and then see if you can write what the products of these 4 reactions are. And I'll go over them. Okay, so just going through the 4 reactions, we had A substitution with ammonia. Of course, the chlorine is getting replaced by the amine group, and here we've produced ethanamide. Or we could have a substitution with water. The ethanoic acid is, the chlorine from the ethanol chloride is replaced by an OH. We get ethanoic acid. Remember, these first two, we're also going to produce hydrochloric acid, HCl. And in fact, we produce that as an extra product in all of these reactions. Then we've got the condensation with the 2-aminoethane, or we might call this ethane 2-amine, which is the more correct name. So we're going to add those two together to make this amide. You don't need to know how to name this amide. We don't need to remember the name for secondary amides. And the last type of reaction, an esterification reaction, where we make an ester. Again, remember these last two will also produce hydrochloric acid. And notice too that when we do the esterification reaction involving an acyl chloride, we don't need a catalyst. So when we did esterification with an alcohol and carboxylic acid, we needed concentrated sulfuric acid. Acyl chlorides are so reactive, we don't need to add extra catalyst to make the reactions happen. It's just going to get in there and react with the alcohol, join together and make that HCl. Okay, hopefully this video has been helpful. Share it and like it if it has been, and look out for the next video, which will be on triesters.